Student, now we are going to learn methods to integrate. First one, suppose we got a c into f of x dot dx. How to evaluate this one? Let us see. You have to take the constant out and then you have to evaluate f of x dot dx. Like that, suppose you are having composite functions f of x plus g of x dot dx. Then how to evaluate means first you integrate f of x dot dx plus then integration of g of x dot dx. Student, if go to f of x, suppose you got f of x minus g of x, then integral f of x dot dx minus integral f of g of x dot dx. Okay, now let us learn some problem based upon this integration. Question number 1, evaluate. Three x square plus 1 into dx. We got like this. This is integral 3x square dot dx plus integral 1 into dx. So you take the constant out, x square dot dx plus integral dx is x. This is x to the power of n formula, x cube by 3 plus x, that's equal to x cube plus x. This is the result. Suppose we learn next problem. Let us go to the second one. Evaluate 3x square dot dx from the limit 0 to 2 is given. Limit is given, lower limit 0, upper limit 2. Integrate x square. If you integrate x square, we will get 3 x cube by 3. Then lower limit, upper limit to be applied 0 to 2, that is equal to x cube 0 to 3, this is 3 cube minus 0, 27 unit. Okay, shall we go to the next problem? Question number 3. Evaluate sin x dot dx 0 to pi by 2. Integral sin x dot dx integral sin x dot dx. Integral sin x is minus cos x. You have to apply the limit, upper limit and lower limit. You take the minus outside, then cos of x, cos pi by 2, upper limit value, minus cos lower limit value, that is minus cos 91, 0, minus 1, that is equal to plus 1. Student, shall we take another example? Evaluate integral dx by x a to b. Student, integral dx by x is equal to log x a to b. That is equal to log b minus log e. Log a minus log b can be written as log a by b. Here we got log b minus log a, therefore log b by a. Okay, student. Let us go to the very interesting sum now. Problem number 5. Find the area of a circle of radius capital R. Very interesting. Using integration, we are going to learn the area. This is the circle of radius R. Here the radius, how this area depends on this radius, we have to get the relation. Area is the function. That function depends on radius. That relation we have to get it. And then we have to integrate to get the total area. Okay. The whole area of the circle can be divided into number of elements. The number of elements that you divide is very important, because you can divide this area into different shape of elements as you like. But that element must be very convenient for us to calculate area of that element. I take the element like this. Listen. Will it be convenient for us or not? Let us see. Like this, if I divide, look at this area. Of this element, not identical with this. And moreover, while moving from left to right, the height uniformly increases up to middle and then uniformly decreases to 0. Increasing and then decreasing. It is not advisable to divide such element. There should be an uniformity, whether must increase or must decrease. And this element area, this area of a rectangle, we can take it. No doubt at all. So we can sum up, but it is very difficult to calculate because there is no uniformity of variation. The area of the elements while calculating, the height slowly increases up to middle and then decreases. There are two variations. It is not advisable to take like this. Okay. Let us drop this type of division. So, not advisable to use such a type of division. Leave it. I take another type of division. Division of elements. Number of circular elements. Each element's thickness is a dx. I am going to divide into concentric circular elements. Among that, I am going to consider one of the element of radius x. and thickness dx. Look at this circular elements of thickness dx and radius x. Area of this shaded portion I am going to calculate. For that, I can cut this element and stretch the element like this. This is the element if I stretch it. Less is the thickness of this element dx. More is the straighten of this elemental area. There will not be any curve there, but you can straighten it perfectly. At the time you look at that, this element area is sum of two triangles, one rectangle. If delta x tend to 0, then area of this triangle can be negligible. Only you can consider area of the rectangle. What is the area of this rectangle? The length of this rectangle is 2 pi x, thickness dx. Therefore, area of this element I take it as dA is equal to 2 pi x dot dx. Now I got the function area in terms of radius, the relation I got. Afterwards I can use this integration to calculate the area in between two limits. What are the limits? If you take such a element at the center, this radius is 0. If you take an element at the edge, the radius is r, capital R, that is given. So, integration limit, you have such elements whose radius varies from 0 to r. Therefore, to find the total area, integrate the above equation from x is equal to 0 to r. Integral dA is the total area, 2 pi is constant out of this integration, 0 to r x dot dA. Then area is equal to 2 pi, then this is x square by 2, 0 to r. And area is equal to 2 pi r square by 2 minus 0. Therefore, area of the circle is pi r square. Student, now you understood how this formula area of the circle came. It's very interesting. Shall we calculate area of a triangle? Another example. Question number 6. Find area of a triangle of height h, base b. And base b. Shall I take a right angle triangle? This is the right angle. Base is b, height is h. Now, I have to divide this triangle into number of elements. Each element area we have to calculate, need not, only one element enough. Then area as the function of this base and height, or height and base, or some constant you have to get it. in terms of area function, in terms of constant and some variable h or b or theta, like that we have to get it. Then we can integrate it. Shall we divide into number of elements? Like this. I divide this element into number of elements. Among that, this is one of the elements. I calculate the area of this element. This look at this area. Dear student, I have selected one element at x distance from origin. I take this is the starting point, whose height is y and thickness is dx. ds is the thickness. If dx tend to 0, delta x tend to 0, this area of this triangle is negligible. So you will calculate only area of this rectangle. Now area of the element. dA is equal to y into dx. This y value varies from 0 to h. Remember, y is varying from 0 to h. But you should calculate y as a function of x. Then only we can integrate it. Look at this triangle. I take this angle is theta. Then what is tan theta? Tan theta is equal to y by x. From the graph, from the diagram. Y is equal to tan theta is equal to y by x. Then y is equal to x tan theta. Here theta is constant. Therefore, dA is equal to x tan theta into dx. Here variable is x. Tan theta is constant. To find total area, integrate the above equation from x is equal to 0 to b. Integral dA is equal to tan theta 0 to b into x dot dx. Total area is equal to tan theta x square by 2, 0 to b. From the triangle, again tan theta you can take. If you take the whole triangle, tan theta is equal to b by h you can draw. Sorry, h by b. H by b into b square by 2 minus 0. That's equal to 1 by 2 h b. That is half into base into height. We got it. Area of the triangle. Student, I hope that you have enjoyed this integration. Student, we go to the next problem. In the given graph, find area under the graph from the limit x is equal to a to b. What is graph that is given? This is a graph given to you. Also the function y in terms of x is given. Y is the function of x such that y is equal to x square. Go to the graph. We go to the solution now. This is the graph given to you. This is x is equal to a. This is x is equal to b. In between a, b, you are asked to calculate area. So what to do is, first of all, select an element at x distance from the origin. This is the element of thickness dx. This element is look like rectangle if thickness is negligible. This height is y. It is at x distance from origin. Then area of the element dA is equal to y into dx. Y is the height of the element. Dx is the thickness of the element. This is the element. This element is look like rectangle if delta x tend to 0 or dx tend to 0. Y function given as x square dot dx. Therefore, to find the total area, you have to integrate in between a to b, x square dot dx, that is equal to x square by 2, 0 to a, and a is equal to x cube by 3 from the limit 0 to, the limit a to b, and area is equal to b cube by 3 minus a cube by 3, the area is equal to b cube minus a by 3. This is area under the graph in between x equal to a to b. Okay, student, I hope that you have enjoyed a lot in the integration. Thanks a lot, student. Thank you very much. I hope that you have understood the basic concept of integral calculus as well as differential calculus. Thank you. Meet you again.